Hi, welcome to Sunil Maths tutorial, functional analysis, class number 58. In this video, we learn a theorem. Depends upon the real and imaginary parts of the transformation or operator. Let us see the statement of the theorem. If capital T is an operator, if capital T is an operator on capital H, which is a Hilbert space, then capital T is normal if and only if its real and imaginary parts, commutates. So I repeat the statement, observe that if capital T is an operator defined on capital H, then T is normal operator if and only if its real and imaginary parts commutates with one another. Right? Let us prove this statement. Let capital H be a Hilbert space. And capital T be an operator on capital H. T be a Hilbert space and H be a Hilbert space and T be an operator on capital H. Now let us define T1 and T2 be real and imaginary parts. Of the operator capital T. By the definition of real and imaginary parts, T1 is equals to T plus T star by 2 and T2 is equals to T minus T star by 2y. This is the definition of real and imaginary parts. Now we are going to find adjoint of these operators. T1 star is equals to T plus T star by 2 whole star, which gives a result of T star plus T by 2, which is nothing but T1. It means T1 star is equals to T1. It means T1 is self-adjoint operator. Next, in a similar manner, let us find T2 star. T2 star is equals to T minus T star by 2i whole star, which is equals to T star minus T star whole star by minus 2i. Because of, remember that I star is equals to minus I. Which is equals to T star minus T by minus 2i. Again, this gives a result of T minus T star by 2i, which is nothing but T2. Therefore, T2 star is equals to T2. This condition also shows as T2 is self-adjoint operator on the Hilbert space capital H. So both real and imaginary parts of T are self-adjoint operators. Therefore, both T1 and T2, real and imaginary parts of T are self-adjoint operators. Again, since T1, T2 are real and imaginary parts of T. So this T can be written as T1 plus I into T2. Now, this is the concept. Our aim is to show that we have to prove that T is normal operator, implies and implied by these real and imaginary parts are commutates. It means T1 T2 is equals to T2 T1. Suppose T is normal. First part. Suppose capital T is normal. If capital T is normal, then what we have? T into T star is equals to T star into T. T into T star is equals to T star into T. Now calculate t into t star, which is equals to t plus I into t2 into t minus I into t2, because simple, t star is I minus t minus I into t2. Now multiply this. Here I have to write t1 t1. So multiply this, t1 square plus t2 square plus I into simply t2 t1 minus t1 t2. Let it be equation number 1. In a similar manner, t star t is equals to t1 minus I t2 into t1 plus it2 into t1 plus it2, which gives a result of t1 square plus t2 square plus I into t1 t2 minus t2 t1. Let it be equation number 2. From equations 1 and 2, the left hand side are same. You see here, the left hand side are same, t star t, because they are equivalent to one another. T star is equals to t star t. Hence, applying this condition for from equation 1 and equation 2, so we simply get t2 t1 minus t1 t2 is equals to t1 t2 minus t2 t1. So you can rearrange this. T2 t1 plus t2 t1 is equals to t1 t2 plus t1 t2, which completely gives a result of 2 t2 t1 is equals to 2 t1 t2. These two get cancelled on both sides. So we simply conclude that t1 t2 is equals to t2 t1. Therefore we take that t is normal operator. We prove that the real and imaginary parts are commutates with second one. T1 t2 is equals to t2 t1. So this is the first part of our theorem. Now we are going to prove the converse part. In the converse part, assume that the real and imaginary parts of capital T commutates. That is, t1 t2 is equals to t2 t1. Let it be equation number 3. We have to prove that t is normal. We have to prove that capital T is normal. Right, from equation 1 we have equation 1. So by using this equation 1, t star is equals to, from equation 1 we have t star is equals to t1 square plus t2 square plus I into t2 t1 minus t1 t2. Now using equation 3, this becomes 0. So which gives a result of t1 square plus t2 square. Similarly, from equation 2, you get t star t is equals to t1 square plus t2 square. Let it be equation number 4 and let it be equation number 5. Now from equations 4 and 5, we conclude that t star is equals to t star t. This is nothing but the operator t is normal. This completes the proof of our theorem, hence proved. So you observe that, so any operator on t is normal if and only if its real and imaginary parts of the operator commutates with another one. In the next video, we learn unitary operator and the theorems depends upon unitary operators. Keep learning. Wish you all the best.